So for this one, you'll notice we have a squared. A is also a squared. We have b and b squared. It's also b and b squared. And the center is still the product doubled, but you'll notice when you subtract, the middle one is also subtracted. For this one, they're all addition. The last one is addition because when you square a negative, it becomes positive. And so this is a square of a binomial. It ends up with the first one squared, the last one squared, and the multiplication of product of the center doubled, all right? And this will always be the case. So look at the first example here on page 475. If I want to find these, you could FOIL it, and you could separate them, x plus 7, x plus 7. Or you could do your shortcut. So if we did just our shortcut, we're going to say the first one, we're going to say x squared, all right? And then we are going to multiply our x and our 7, and we're going to double it. And then the last thing is the 7 will be squared. Okay, and this is technically like that. And so we're going to end up as our final answer with x squared plus 14x plus 49. All right, and you don't even have to worry about foiling. Now, if you wanted to check it, you could FOIL it. And by foiling it, I mean you're going to actually set these out. So you're going to have x plus 7 times x plus 7. So you just have it twice. That's what you do. Then you would have x times x, x times 7, 7 times x, and 7 times 7. And you'll see that you end up with x squared plus 14x plus 49. Because that is the rule for squaring a binomial. All right? Look at the second one. We have 4k is our initial, so 4k, and we're going to square that. Minus, so we're going to leave that a minus, and we're going to say 2 times 4k times 3. And then we're going to square the 3. So our answer here is going to be 4k squared. What happens there? Square your 4 as well, right? So we have 16k squared. What is 2 times 4 times 3? Right, so we get 24, and then we get plus 9. So first one squared, multiply the 2 and double it, and then the last one squared. That is your shortcut for squaring a binomial. So go ahead and try these, finding the square of those 4 using fine when you're talking about, 1 through 12, or even larger if you know the larger numbers. But when you square something like 51, then you start to do long multiplication. 51 times 51, multiply, put a 0, multiply by 5, add them up, etc. Right? You can use this concept of squaring a binomial to do this, and basically can do it in your head. So 51's not easy to square, but 50 is. And so I could rewrite this as 50 plus 1 squared. We would all agree that's 51 squared. And so I apply the same method. I'm going to say, well, I will square the 50. I will double the product. And then I will square the last one. 50 squared, that's 25 and then 2 zeros, right? 2 times 50 times 1, well, that's just 100. 1 squared is just 1. So 2601 is the square of 51. And thinking that you could probably remember 25, 101 in your head, you could probably do 51 squared in your head. And so this is mental math, meaning instead of doing long multiplication to do 51 squared, you can just very quickly say, well, 50 squared plus 100 plus 1, and then have the 51 squared pretty quickly. For 49, same concept. So you're basically trying to say, what am I closest to? I would not say 40 and 9 here. That would not be the easiest way to do that. I would actually say 50 minus 1. So if I did 49, I would use the same concept, but do 50 minus 1 squared. Same thing. I'm going to square that 50. I'm going to subtract the product, doubled. And then I'm going to square the last one. So again, I would have 2,500 minus 100 plus 1. And then obviously 2,401 for this one. So very quickly you can square large numbers if you get it closest to what you're trying to square, and then subtract or add from there. So go ahead and set these up with squaring a binomial, and then calculate the square of these four numbers. When you're multiplying it, it doesn't look like it's going to do the difference of two squares. But what you'll notice is instead of a plus b times a plus b, so we've looked at squaring something like this, which would be the same exact sign and the same things on the inside. You'll notice here we have different signs. So here we have a plus and a minus. Now the a and the b are the same, so the first and last term are the same, but it's plus and minus. And so what happens when you do this, if you were to FOIL, I would get a times a, which is a squared, a times negative b times a, and b times negative b. All right? And what you'll notice in the center is that you have a negative ab and a positive ab, which cancel each other out. And so you end up with just a squared minus b squared. All right? And so that's why it's called the difference of two squares. When you have binomials that have the same exact terms, but the center sign is different, you have a plus and a minus, you are going to end up with the first term squared minus the second term squared, always. So let's look at example 4. These are very easy to find because you don't even have to worry about a center term at all. If you notice, if you recognize that this is a plus minus of the same exact terms, Then you literally just have to take the first term, which is t cubed, and square it. And then you subtract the second term, which is 6. Now you do have to apply your properties of exponents. What happens when I take a power to a power? What do I do with these? You don't add. You add when you're multiplying like bases. What do? Yeah, you multiply. So 3 times 2 is 6. So this is t to the 6th power minus 36. All right, and so you end up with a final answer of t to the 6th minus 36. And you don't have to FOIL it at all. You literally square the first term, subtract, and square the second term. So go ahead and try these. A, B, and C. So on the first one, you square the d. That's where you get the d squared. Square the 11, 121. D squared minus 121. C squared squared. You're going to multiply those. So 2 times 2 is c to the 4th. You always double this guy. And then minus 8 squared is 64. 9v cubed squared. You're going to square the 9, 81. Square the v cubed. You double that exponent. So that's the 6th. And then square the w to the 4th. You double that exponent when you square it. So that's to the 8th. All right. A lot of times people will try to square these exponents. You're not squaring the exponent. You are power to a power. So 4 times 2, you're going to double it. So here we're not squaring a number. We're just multiplying 2 rather large numbers. In elementary school, you would have laid these out. You would have multiplied by the 8, put a 0, and then multiplied by the 7, and then added your answers. For something like this, now obviously it's only going to work if it is the same distance away from a whole number or from a multiple of 10, something like that. But in this case, these are both 2 away from 80. And so I can rewrite this, the 82 I can rewrite as 80 plus 2. And the 78 I can rewrite as 80 minus 2. So they are the same distance away. So this is an a plus b, a minus b. And so to do this, I can square the 80. And then I can subtract the 2 squared. 80 squared, I just take the 8 squared, which is 64. And then I put 2 zeros because I had a 0 here. And then square the 4, right? And so when I do that, I can subtract just 3 from it. 6396. Which seems a lot faster than doing long multiplication here for those 2-digit numbers. All right? And so if they're the same distance away from the same whole number, you can do plus minus. And just square both and subtract. So go ahead and try 5A through D. So for this first one, they are both 2 away from 20. So 20 minus 2, 20 plus 2. So you square the 20, subtract square the 2 squared. These are both away from 20 as well, 1 away. So 20 minus 1, 20 plus 1. 20 squared minus 1 squared. These are 1 away from 60. 60 minus 1, 60 plus 1. 60 squared plus 1 squared. These are both 3 away from 90. 90 minus 3, 90 plus 3. 90 squared minus 3 squared. On your test and quiz, I actually require this row right here. So I require you to show me how it is set up like a difference of 2 squares. I don't require you to show me the second row, but I do require this. Set it up like a difference of two squares and then give me the answer. You can certainly show the rest of your work, but I do require this row right here.